Here's an explanation on how to calculate the load requirements for a generator for a 3-story apartment, classroom, and office building. This explanation assumes a 3-phase, 4-wire, 240 volts to ground 415 volts electrical system, common in Australia. Let's start with the total connected load service requirements. We need to calculate the wattage of each appliance and lighting and then sum them up. First, the air conditioning units. There are 6 air conditioning units at 3,200 watts each for the offices, totaling 19,200 watts. Additionally, there are 2 air conditioning units at 6,000 watts each for the apartments, totaling 12,000 watts. Next, let's look at the refrigerators. With 3 non-industrial refrigerators, we can estimate their power consumption at 1,000 watts each, totaling 3,000 watts. The washing machines are estimated at 1,500 watts each, totaling 3,000 watts for the 2 machines. We have 4 water circulating pumps. Assuming each pump is 1/4 horsepower, we can estimate their power consumption at 750 watts each, totaling 3,000 watts. For the 3 microwaves, we'll estimate their power consumption at 1,200 watts each, totaling 3,600 watts. Then there are 25 ceiling fans, estimated at 100 watts each, totaling 2,500 watts. For the lighting, we will assume 10 watts per square foot for the 1,568 square foot building per floor, which totals 15,680 watts. Finally, there's an 80 amp feeder to another building. To find the wattage, multiply 80 amps by 240 volts, which equals 19,200 watts. To find the total connected load, add up all the individual loads. 19,200 watts plus 12,000 watts plus 3,000 watts plus 3,000 watts plus 3,000 watts plus 3,600 watts plus 2,500 watts plus 15,680 watts plus 19,200 watts equals 70,180 watts. Now, consider the main breaker size. The main breaker should be rated for at least the total connected load. In this case, a 100 amp main breaker is recommended. Moving on to the minimal generator size. This depends on which loads the generator needs to power during an outage. For emergency backup, the generator should power essential loads only. These include refrigerators, water pumps, lighting, ceiling fans, and microwaves. The essential load wattage equals 3,000 watts for the refrigerators plus 3,000 watts for the water pumps plus 15,680 watts for lighting plus 2,500 watts for ceiling fans plus 3,600 watts for the microwaves, which totals 27,780 watts. Therefore, a 27 kilowatt generator would be the minimal size for emergency backup. Now, if the generator is not required to power the air conditioning units, the load requirements are significantly reduced. The essential load wattage without air conditioning units is 18,780 watts. In this case, a 20 kilowatt generator would be sufficient. Finally, for information on Australian electrical codes, Australia follows the AS/NZS 3000 series of electrical codes.